So you have been introduced to the Claisen reaction, and we've gone through the aldol reaction. So with the aldol, we discussed the possibility of a mixed aldol reaction and the possibility of an intramolecular aldol reaction, and the same two variations can be thought about with the Claisen reaction, reacting esters. So here is an example where we have two different esters, and we don't want to get a mixture of products, and the only way that we can get a single product from this mixed Claisen reaction would be if one of the esters is converted 100% into an enolate and the other one is not the enolate at all. And so here is one of them is going to be the nucleophile and one of them is going to be the electrophile, and there will be no mixing of that. So how can we pull this off? First of all, if we have an ester that has no alpha hydrogens, then we don't have to worry about this one getting deprotonated and becoming the enolate. So this one is going to be the electrophile, and the other one is going to be the nucleophile, but now we have to, if we add sodium ethoxide, we said much less than 1% of this is going to be the enolate. So if we have a little bit of enolate present, it'll react somewhat with this ester and somewhat with its own ester conjugate acid there. So we have to convert this somehow to, we need to pull off one of these acidic hydrogens, and we need to pull it off completely. So we need a little stronger base, actually a much stronger base. So sodium hydride, as you know, is a source of H-, extremely strong base. The conjugate, what's the conjugate acid of hydride? H-. What happens if you add a proton to H-? You get H2, you get hydrogen gas. What kind of acid is that? Well, it's no kind of acid at all. It's got a hydrogen attached to a very electropositive element, a hydrogen, and so very, 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 very weak. Well, it's a non-acid, and so its conjugate base is a very strong base. So let's see what happens when we dump in the base here. That will come around and pull off one of the acidic hydrogens, forming the enolate. Then that enolate, which is going to be our nucleophile, going to attack two steps. ACL substitution, first an addition, onto dumping the lone pair onto the oxygen, and then an elimination, kicking out the leaving group. And we will get then our final product, which, let's see, here is our original enolate, and then that is attacking the carbonyl, kicking out the leaving group. So here's the carbonyl, and then we have the attached benzene ring here. So alpha, beta, keto ester as our final product there. Okay, so this is a mixed Claisen reaction, clean reaction, because we had only one of the two compounds had acidic hydrogens, and we added a base that was so strong that it converted 100% into the final product. And of course, here then we have this acidic hydrogen, and this is completely converted into the enolate, and it's not the final product, and then we have to add H3O again to add the proton on. Okay, so one way to make the mixed Claisen work. Let's take a look at an example of an intramolecular Claisen reaction. A molecule that has a couple esters on the same molecule. And let's see here. 1, 2, 3. So if we start out with this diester and we add sodium methoxide, and step 2 enough H3O to neutralize it, then we can look and see what happens. And so this is a symmetrical one, and so all of our acidic hydrogens are the same. We can deprotonate one side, and if we do, then we can form an enolate here, and that will attack here, addition, followed by elimination, and we will form a 1, 2, 3, 4, 5, 6-membered ring. So again, let's number these so we don't get ourselves confused. 1, 2, 3, 4, 5, 6, 7, and we said we were going to form a 6-membered ring. So let's start out drawing our product like this, and the ring is including carbons 2 through 7, so we can number those 2 through 7, and then go ahead and draw in the rest of the stuff. So on carbon number 2 we have an ester hanging off, so we have our original carbon number 1 ester here. Then we have on carbon number 7, we used to have the ethoxy group that got kicked out, and here is the carbonyl that forms. So here's our product from a intramolecular Claisen reaction. And where is the new bond that forms? Again, this is a beta ketoester. The new bond that forms is between the alpha carbon and the beta carbon. That was our new bond that forms. So this will work if you can form a 6-membered ring or a 5-membered ring. So it's the same story as the intramolecular aldol reaction. And again, you'll have a couple practice problems there, so you can learn how to work forward and then think backwards as well.